Today's video is for you if you are that DIY dude at home. You do basic DIY stuff around the home, but also on your car. So you know how to change a tire and you know how to change a radiator hose and a serpentine belt and things of that nature. But you want to expand your work envelope towards that metal trade stuff. So you want to make stuff out of metal, fabricate this and fabricate that for camping or around the home, build a workbench, whatever it takes. And you also want to approach working on your car and do more advanced jobs with increased competency and confidence without breaking the bank. So we're not going to be talking about how to buy a 2.5-ton Bridgeport clone knee mill or something of that nature, although down the track we could do that. But today we're just going to talk about expanding that work envelope affordably so that you get the most bang for your buck and, I guess, the least disappointment. If you're new to this channel, my name is John and I am an old school mechanical engineer. I first walked into a tool room aged just 15, which is near enough half a century ago now, and I worked for a cranky old toolmaker who spent rather a lot of the first several weeks to months just shouting at me because I was doing things wrong and or dangerously. And then over time he shouted at me less and less and less and allowed me to do more and more and more. And here we are, nearly half a century later. So the reason I'm doing this video is because I see so much stuff on YouTube where DIYers teach other DIYers to do stuff badly, and I frickin' hate it. So there's going to be a few videos like this coming up because it's a pet subject of mine, a bit of a pet peeve, and I really want you to be able to take your DIY skills package and upgrade it without hurting yourself and with the minimum pain to allow you to do the maximum project, whatever you want to be able to do, whether that's just, I don't know, fabbing up a barbecue plate or a couple of stools for your barbecue area, whatever, some camping stuff for your 4x4, or just working on your car. If you've never worked in industry, it's structured in kind of an interesting way, and I trained in the railways, so that was in heavy industry, and I spent a lot of time in those workshops in various different sections. So you've got your boiler makers, for example, and they tend to specialize in one area, which would be fabrication. So they're really good at cutting stuff up and making it fit together and fabbing it together by welding it or bolting it or riveting it, whatever the hell the job calls for. That's what they do. And then you've got your precision specialists like your tool makers and machinists, and they exist in machine shops. They use surface grinders and milling machines and lathes and things of that nature, and they make some really cool shit, and they think about dimensions that you can't resolve with your eyes. They're always talking in thousandths of an inch or microns and things of that nature. 100 microns is the diameter of a human hair, or about 4/1000ths of an inch kind of thing, okay? So they're thinking about that all day long. They're really good at mental arithmetic, go figure. And then you've got your generalists in the middle. I'd categorize them as being fitter machinist types, right? So they do a bit of everything. They bolt stuff together. They're the guys who you get, where I trained at least, to put superchargers on big fat V16 diesel engines and then lift the whole thing with a crane back into the locomotive and bolt it down so that it lines up with the generator that makes the voltage to drive the traction motors, blah, blah, blah. So the tradies in the metal sphere that you're most likely to deal with are mechanics, right? Because you take your car and you get it serviced. And to me, mechanics are kind of a really specialized fitter machinist type. They're the gynecologist of the fitter machinist universe because they're always working in spaces where you can't clap, kind of thing. Because car makers don't make cars to be worked on. They make them to assemble them, and they make them to fit maximum componentry in minimum space, kind of thing, hence the gynecology reference, right? There's no space down there in a car, and that's why mechanics need so many specialized tools, why they curse so much on the job, because there's never enough space to do the job, kind of thing. So anyway, what you need to do is think in terms of the work envelope. Your tools in your tool bag have a work envelope. And that's partly dependent on the tools, and it's partly dependent on you. I'd argue that you get 3 different dudes with exactly the same tools, and there'd be a substantially different work envelope between the 3 people, potentially, because of their differing abilities to improvise, adapt, and overcome to different situations using the standardized tool package, if you like, okay? But given that you're only one dude and you've got the tools that you've got, let's just assume that you've got basic spanners, sockets, you've got battery drill and a driver and pliers and a hacksaw and an angle grinder and the basics, the pliers, if I said that already, I'm sorry. But anyway, you've got those basic tools, but you want to expand your work envelope over here and do more hardcore metal type stuff. What do? I've got 12, actually 13 different tools for you to consider, and my hope is that they will stretch your work envelope using minimum cost for maximum benefit. So let's get into that. Let's count them down from the most useful down to an esoteric one right at the very end. Here we go. The first tool I urge you to acquire is a soft hammer and not one of these, okay? These have their place. These plastic hammers, they're great, but they're not the one that I think you should get first. I think you need one of these. This is a brass-headed hammer. And as you can see, over the intervening 40 years since I first procured it, it's mushroomed up a bit, but it is still fully functional and good to go. It's on its second handle, but I don't envisage wearing out the head in my lifetime. The brilliance about having a soft face hammer is if you've got this kind of thing in your toolbox, like a framing hammer, they're terrible at metalwork because they're optimized for wood. And if you've never worked in the game, you might think that the obvious engineering hammer to get is a ball peen hammer. And it's great to have a ball peen hammer because they are quite useful and they're better at metalworking stuff. They're good for riveting stuff over and they're good for hitting chisels and whatever else, right? But they're not as useful as a soft hammer. The superpower of a soft hammer is that it doesn't damage the thing that you hit with it. So, for example, if you take a flywheel or a cylinder block to a machine shop and get the flywheel resurfaced or get the deck of the block resurfaced, they'll give you a couple of dowel pins. A lot of flywheels have dowel pins which locate the clutch housing on the flywheel face, right? And the dowel pin is kind of a light interference fit into the flywheel, and ditto with the heads, okay? Cylinder heads are located on the deck with those pins that come out of the block, and they're held down by the bolts. So the retention is the bolts, but the location is the pins. Getting the pins in requires, because you usually don't have access to a press big enough, you just nudge them in with a hammer, and usually you'd use, I don't know, some retaining compound or something like that just to make sure that they don't come out in service, although they're pretty well retained in the case of cylinder heads, or not so much in the case of the clutch plate thing. So anyway, soft-faced hammer doesn't damage the dowel pin. A dowel pin is like a precision ground piece of round stock, and it's designed to just fit into a hole that's precisely reamed, and it's a beautiful marriage because you just get them in place like this. Your brass hammer doesn't damage the pin, and even if you slip, because I don't know, some chick with great cans walks past at an inopportune moment and you're only human, you've only got the requisite male bandwidth, can't concentrate on hammering and chick with great cans at the same time, then you slip. If you slip with one of these, you're going to put a ding in the deck of the block or the face of a flywheel, neither of which outcome is optimal. I think you'd agree. So your soft-faced hammer is really good. It's also beyond adequate to hit a chisel or a center punch or anything of that nature. There's more access in the gynecological spaces in a car as well. And that's important because less handle means more access. And if you've got a frozen fastener on some suspension component and you're using a wrench to break it free and it's just not cooperating and you're giving it maximum U, okay? to try and undo it. One of the best things you can do in this situation is hit it with a hammer. And it's better if you don't hit it with this one, even if you can fit it into that space. It's better if you hit it with this one because brass is slightly denser than steel. I think it's about 1/16 denser. Steel's about 8 tons, a little bit less than 8 tons per cubic meter. And brass is 8.5. So you get a little bit more density, heavier hammer for the same volume, in other words. And also, the soft face doesn't ding the chrome and cause it to flake off, so that's great. Incidentally, I know it sounds to some like being a bit of a butcher, hitting a wrench with a spanner, with a hammer, but in fact, it's a really good technique to learn because impact is great at loosening stuck fasteners, much less likely to shear off the fastener, and the shock load from the impact is much more likely to fracture whatever is holding that fastener in place, usually a bit of corrosion, right? So hitting a wrench with a hammer is not butchery at all. And this is also a really good first machining project if you're interested in doing something like that, because I just priced it up. You can get a piece of round brass bar about 38 or 40 millimeters in diameter like that from, I don't know, you could go to Edcon Steel, just EDCON. They're not sponsoring this package, but if they want to, I'm all ears. You'll get 100 millimeters length of 38 mil brass round bar for about $35. And if you want square bar to make a hammer, I don't know, more like that, then you can get that. You'll still get change out of about $45 for the same sort of mass of hammerhead. And then you can just put a hole in the guts of it and there's your hammer, right? And it'll last you 40 years and be super useful. The other material you can get for hammers is, of course, copper. The typical copper, because copper's so freaking expensive, is a cast iron sort of head like that with copper slugs at each end. These are really good for assembly too, and the copper is slightly softer, so more forgiving. The ones we saw in industry when I was a kid in my 20s were these Thor ones like this. They're awesome as well, but quite expensive. So brass is the sweet spot for value in my estimation. Also really good if you want to get into machining, because occasionally you just have to tap something into place. It's running a little bit eccentrically on a 3-jaw chuck, and you put an indicator or something on it, you can tap it more concentric. And on a milling machine, you can gently hammer the stock down so that it seats properly in the parallels. On a drill press, you can nudge the vise or the stock in the vise into position so that the hole is more precisely where you want it. So the brass hammer gets 13 points out of a possible 10 from me. Make sure you have one in your toolkit. This video is sponsored by OLIGHT, and they're working with me on this one because a torch is a proper superpower in this workshop and out on the road working on the car environment. OLIGHT has a massive Halloween sale on right now, which will wrap up in just over a day's time relative to the publication of this video. Midnight on the 23rd of October, which is a Thursday. That's it, dude. So if you want to pick up a big saving, they always do really good savings in their sales, OLIGHT. The reason I work with them is because I'm in love with my Warrior Mini 2. I carry it with me everywhere. I feel like I've left home without pants on, which only happens a couple of times a week, I'll have you know, even at my advanced age. The reason I love this torch is because A, it's been super reliable. It's got this switch on the barrel that allows you to access all the different brightnesses, but the superpower for this torch is, and all the Warrior torches, you pull them out of the pocket. If you need light in a hurry, your thumb can always find the back. Boom, there you go. Bright light in a heartbeat, which is so good in so many different scenarios, potentially. The other torch I really like, which I have in the car and in the workshop, is this thing. It's called a swivel, and it is a work light and also a torch. These are not the sum total of its tricks. The brightness, as you can see, is variable, but it swivels, dude. You can angle the work light wherever you want, and it's magnetic, so you can stick it to anything ferromagnetic on the outside of your car. to help you change a wheel in the middle of the night in the boonies. Not only that, this thing's a carabiner, so you can hang it from the bonnet and it can shine light wherever you need it to shine while you figure out what's gone wrong. So that is quite clever in my book. And these things are cheap too. Like they're ABS plastic, virtually indestructible, and I think about 40 bucks. So anyway, there'll be a code in the description for non-sale items. What they are doing at the moment is concentrating on Halloween, and there is a bit of whimsy there. OLIGHT is pretty good with the Halloween whimsy. They've got this thing, it's called an O-Clip Pro, and you can see that the Halloween aesthetics are well and truly at play here with the blood spatter and the zombie green, blah, blah, blah. But O-Clip is really useful. And one of the things about torches is the bigger the torch, the more the impediment to carrying it around in your pocket. And the most useful torch is the one you've got on you. So you want to remove as many impediments as possible to carrying one. And this is so tiny, dude. It's handbag sized, and you can clip it to a shirt or just about anything else. And it's got so much functionality. Like it's got this red light, which is great for walking around the bush at night because red light does not destroy your night vision. But it's also got signaling strobe. So if you break down and you need to signal, you can do that. It's got a spot beam and a flood beam as well in various brightnesses. So you got red, spot, flood, beautiful. It's also magnetic. So if you need it to help you with some work you're doing on the car, it can stick to anything ferromagnetic. You can clip it to your backpack, the front of your polo shirt, the front of your t-shirt, whatever. Both hands will be free. It's just a really versatile, compact, lightweight light. There's no excuse not to carry it. Recharges with USB-C. The Baton 4. I love these Baton premium kits because I kind of like the bats and the purple as well in the zombie aesthetic. So if you're getting a present for a kid or something, that would be really clever. And the kid would love that. But the thing I love about these is that there's a power bank as well as the torch. The torch is pretty cool, I have to say. There's plenty of different brightness options there, and it's the same cycling through barrel switch option. Most OLights rely on the same functional logic. You can carry the torch. It takes up no space, weighs nearly nothing. It's super bright on the brightest setting. It lasts forever. On the lowest setting, you recharge it in the power bank, which is recharged by USB-C. But the interesting thing, I guess, is that I've got a power bank just like that that's been running this whole segment because the camera battery does not have the endurance for a video package this long, but this does. So maybe you don't have to do that, but maybe from time to time you just need to give your mobile phone a jolt, which this will do. This is therefore one thing that does multiple jobs in your bag. You don't need a separate power bank. You don't need a separate charging cable for your torch or whatever, or your phone, blah, blah, blah. You just need the one thing. You've got torch, power bank. It's got multiple functionalities, and therefore it's only one thing to remember to pack. So that's the Baton 4 Premium Edition. 110 bucks-ish on sale right now. And from memory, that's about 25% off, so that's great. If you're into this four-wheel drive adventuring thing, this is a Seeker 4, and it's a really good light for the campsite, right? It's tunable for brightness. You can wind it up and down with the switch on the barrel. Infinitely variable, so that's great. But it's a bit big for the pocket, which is why they've given it this pretty clever pocket clip in plastic. These things are great because the retention is quite positive on the belt and for the torch. But its other superpower is it's got a typical OLight charger on the back of it, but the case has USB recharging. So you've got multiple recharging options, multiple brightnesses, nice wide beam. Great for the four-wheel drive and the camping set, I'd suggest, with the Seeker 4. They are just under 150 bucks on sale right now at 25% off. Also in the zombie green with the blood spatter. So if you've got those young kids and you're trying to get them engaged in the outdoors, these little kind of graphic touches are a great way to do that. I know I spoke earlier about my faithful companion, never leaves my side, the Warrior Mini 2. I do love it, but if you want something just a bit bigger and just a bit brighter, this is the Warrior 3S. You can see how much bigger it is there. It's slightly heavier, but it's not really a deal breaker. I guess you have to decide if you've got that much space in your pocket. And if you do, there's no reason not to carry it, because super bright. It's like a lightsaber, dude. As soon as your thumb finds the end of that torch, lightsaber. But it's the biggest Warrior torch with a switch on the side of the barrel as well, so you can cycle through the different brightness settings, meaning you can just go out into the backyard with a very dim beam like this that won't destroy your night vision if you've got to take the dog up the back. And then, you know, if zombies attack, boom, you've got the bright light just available anytime soon. These things are super tough too. I have torture tested its predecessor and it held up so well. Like, I froze it solid for a week and then I belted it out of the ice and just threw it high up in the air and let it land on the bitumen until it broke. And on whatever it was, go number 17, it landed fair on the bezel and never shone again. But essentially, it wasn't coming out of that test alive, and I think it's testament to just how robust these torches are. They're waterproof and drop tested, blah, blah, blah. And they punch well above their ratings if my torture testing is anything to go by. Anyway, this thing is like just under $135 on sale at 25% off right now. So that's a great deal also, if you can challenge yourself to fit it in your pocket every day without ever leaving it behind, because you know that on the one day that you leave it behind, that will be Zombie Apocalypse Day. Don't do that. Don't forget, the OLIGHT Halloween sale ends at midnight on the 23rd of this month, October 2025, which is a Thursday. So there's only a limited window in which to act. The savings are very real. The products are great. I use one every day. Go for it, dude. There'll be a code there as well that will give you a discount on non-sale items. And I think it will also work outside the sale window. The next thing I urge you to do is stop marking out the job in one of these. The thick marking pen is okay for some work. If you've got 6 meters of pipe and you've got to cut it into 1 meter lengths or something, then okay, mark it out with one of these. But if you're going to do anything that's even vaguely precise, like make 4 legs for a bench the same length, then colour in the leg by all means. Colour it in like that. But dude, do not cut on the line like that. You've got to use a scriber, okay? Because a scriber gives you so much more accuracy. Like, you'll be dead accurate with a scriber. And apologies if you're watching this, it's making your head explode. I'm a lefty, so there's that. But with a scriber, hopefully you can see this. With a scriber, you can see exactly where to cut. There's no ambiguity, because quite often with cutting operations and other machine operations like the location of holes and things of that nature, the width of the pen, like if you've got a big felt marking pen, the width of that line is way too coarse and you could cut in the middle of the line or on the edge, but where are you really supposed to be cutting? You have to be more accurate than that. So get yourself a scriber. The options are, this one here has a carbide tip. That is tungsten carbide. It's the hardest tough material in the world. It's probably about, there are mostly brittle ceramics and diamonds are harder than tungsten carbide, and they're all pretty brittle. So tungsten carbide gets used in industry for all kinds of advanced cutting tools on CNC milling machines and 5-axis this and that, you know, and they often make them with holes down the guts of them so they can inject coolant right into the cutting operation, and the material hangs in really well in these tough environments with maximum depth of cut and high rotational speeds and all of that kind of thing. So the brilliance of something like this tungsten carbide tipped scriber is that it will get straight through the mill scale and actually hoe out a bit of a line. Like, it'll carve out a groove that's only fractions of a millimeter wide in the stock, and then you can feel it with a center punch. You know, so if you have to reference a cross-hatched set of lines with a center punch, you can drag the tip down to the line that you've carved here and then drag it along that line to its partner at 90 degrees. And without even looking at it, you know that the tip is exactly on those crosshairs, which is when it is fair game for your brass hammer, dude. Like, that's a properly Jedi skill that will really up the accuracy of your drilling game. The other type of scriber is this tool steel version, okay? And I guess you'll pay, I'm going to say about $15 for a carbide tip one and about $7 for one of these tool steel ones. Now, get both because they're so cheap, right? The beauty of the tool steel one is you can also use them for just about anything else. They're not quite as hard, but if you need to get an O-ring out of something, you can just get the tip in. It makes a pretty good pick to do that kind of thing. It's also pretty good for unpicking a helicoil that's started to spin or needs to be reefed out of a hole that's previously been repaired, right? And if you ding the tip up, you can sharpen these ones, whereas you need a specialised silicon carbide sort of green soft grinding wheel to sharpen tungsten carbide. Most people don't have that. So very difficult to sharpen and easy enough to chip, okay? So not as durable perhaps, but much sharper, if you like, better for that groove for the Jedi alignment trick. But these things have their place as well. And if you ding the tip, you just sharpen it again on a conventional grinding wheel. If you damage the heat treatment, you get a little blowtorch and heat it up to red, and you just stick it in a bit of water and Bob's your mother's brother. It's hard again. And if you really damage it, do you care? They're like $7 to replace. So no more pens, mark stuff out with a scriber. Your accuracy will be orders of magnitude better, much less cursing on final assembly, I'd suggest. The next tool is a bit expensive. It's from Knipex, who make the world's best pliers in my estimation. They're German made, and this particular one is called the Pliers wrench. The Pliers wrench. And its superpower is the parallel movement of the jaws. So you got one set of ring and open end spanners like this, okay? And quite often you'll be in a situation where you've got to tighten up a nut on a bolt. You need to hold the other end, right? And that's kind of inconvenient, and I know you can use an adjustable spanner for that, so yay, if you want to do that, knock yourself out. I got plenty of adjustable spanners here and they get used all the time. They're great tools. But the Pliers wrench is a brilliant addition for anyone's, particularly car type toolkit, because it's so adaptable. You know, they come in all different sizes. I reckon the 180 millimeter long version is pretty good, and the 250. You've got a great toolkit if you've got one set of quality spanners augmented by two of these. They're brilliant. So you can set them for any hex, and they operate over such a big range. They're kind of good for home plumbing jobs as well, because quite often you've got a big hex there and you generally don't have a spanner big enough like that. And if you use your what an American would call channel locks, they do tend to mar up the fastener a bit, and that might not matter for plumbing at home, but you probably hate it if you do that to a hydraulic fitting on a machine or something of that nature. So you've got your big hex and you can grab it with your pliers wrench like that. The beauty of these is that they also exert clamping force in the way that an adjustable wrench does not. I mean, it'll hold it from counter rotating, but you can't pick it up and put it out there at greater than arm's length while you're putting the bolt through the nut from this end, kind of thing, you know. So you can reach out there and hold it in place without dropping it off some gantry, which is pretty useful. And then if you need to hold it tight, I've got another one of these hexes just in the vise here, right? So if you need to hold something tight like that, it's a one-handed deal. The clamping force depends on the cam action here, which you can probably see there, and that means that you can hold it in place and get it tighter and tighter and tighter just with one hand, just with the pressure of one hand. So it's a brilliant tool. They are quite expensive, but they're a lifetime purchase. and you will use them extremely frequency you'll use them frequency if you've got them in your frickin' toolkit, dude. The next tool is something that you will use all the time. It will save so much cursing and you'll get change out of 20 bucks. I'm talking about the cheap-assed Amazon or eBay magnetic pickup tool. Its superpower is that it is pen-sized and it has a magnet on the end, and every time you drop a fastener, you fumble it and it falls down into that gynecological hellscape of the engine bay of a modern car. And it doesn't even fall through onto the floor these days, does it? It gets trapped in a drip tray somewhere. And then you've got to get it, and there is no access for the human hand down there, and you don't want to lie on the wet driveway in any case. And this was only supposed to take you 30 freaking seconds, and yet here we are. So if your toolkit contains one of these, I don't know, $15 magnetic pickup tools, you just untelescope. And seconds later, cursing averted, swear jar empty, there's your fastener. You get to do whatever you came here for, and it cost you less than 20 bucks. Sometimes you've got a job to do, like fitting this vise to this steel bench, and you want to make it removable. You don't want to get down there with a spanner underneath it and have to muck around with nuts and washers and stuff like that. So it makes absolute sense to drill and tap your steel workbench. Like this web on these pieces of channel that I bolted together to make the bench is like 10 millimeters thick, or 8, I can't remember, but anyway, thick enough to do proper farm work on. And I needed 4 M12 tapped holes in here, M12 course, so by 1.75. How do you mark the holes out? Like, a lot of people get down there with their scriber, or worse, their marking pen, and they template the holes up like that into the bench. And then they kind of eyeball the center, and I guess that's fine if you're going to drill a big clearance hole and put a nut and a washer underneath. But in a lot of machining applications, that terrible level of rough precision is inadequate to the job. It certainly is for something like that, because all 4 of those holes have to line up, and it's kind of a disaster if you're a quarter of a hole out on the final one. Then you have to butcher it, and then you'll think about that every time you use your vise, and it'll do your head in. It'll suck your soul out and leave you a withered husk. So how do you mark those holes out more accurately? And the answer is you buy yourself a set of transfer punches like that. These go from, I don't know, I'm going to say that looks like 1.5 millimeters, something like that. Anyway, one that I would never use, terribly small, watchmaker's transfer punch, up to 13. The big one is 13. I'll just give you a look at the end of it there. It's got a little tiny center punch machined onto the end, right? So the outside diameter locates in the hole that you're trying to mark, and then the center punch marks the center of that hole for you, which is great for exactly this kind of application, because you can clamp the base to the work, then you can mark out the 4 holes, and if you want to, just for old time's sake, you can color in the holes like this, so you can make sure that you're not misinterpreting the result once you remove the base and you start drilling, right? So what you're looking for there is a little tiny punch mark in the center of a piece of blue texture. And if you've got both of those things, blue texture, punch mark, you're in the right spot. Like, you've come to the right spot, dude. Drill here. That's the universe saying drill here. Once you've done that, that's fantastic, right? You can use this concept, right, to do other stuff. When I put these offset vices on the other benches over there, on the other bench, there's 2 offset vices on this big, thick cast iron bench over there. And I couldn't get a full-sized transfer punch in there. So I made a slug, whatever you call that, arbor, I guess. I made an arbor for that, and it's just a piece of round bar with a hole in it, and I cut up one of those old IKEA Allen keys. You should always keep the tool steel this and that gets supplied with anything, because you never know when you might need a bit of medium or high carbon steel to make something bespoke. So this is a 16 millimeter transfer slug, if you like. It goes in the hole in the vise. You put the little tiny punch on top of it, and then you just give it a little tiny kiss, with your brass hammer, there's your hole, right? It's located exactly in the center. And the smaller of the vices needed a 12mm one, so I made that as well. These are just low carbon steel, and I blued them with that Birchwood Casey gun blue stuff, which works pretty well and stops corrosion. So I haven't used these for months. They're not corroded. You just grind a little point on there and then blowtorch, red hot, in the water, good to go. Don't harden the whole thing though, because you want to hit it with a hammer without shattering it. The final thing you can do in the transfer punch domain is you can get one of these transfer punches, which is like having every one of these transfer punches in a pint-sized package. The caveat is that this only works if you've got a flat surface to locate on. So if you've got a cast component that's got a relief in the casting and it's at an angle to the reference surface you're trying to drill through, this will not work, whereas one of these basic transfer punches will. But if you've got that flat surface, then you want to mark one of these holes. You just locate it. I've got to do it down here. Hopefully you can see that. I think you can see that. I'll do it up here. You put this on, you push the sliding bit down onto the reference surface. Little punch goes through. Give it a love tap. Give it a love tap without slipping like that. Checking for girls with great cans out the window. There's your reference hole, right? These locate with great accuracy the concentricity of any hole that you have to mark out accurately where accuracy counts. Like wood, you don't have to worry about that so much because you can massage wood into position. You can drill it after the fact. If it's half a hole out, just ream it out with a twist drill. That's not so successful in steel. So you need to up your game and have a more precise mindset off the bat. There's all kinds of squares you can use for all kinds of applications, for all kinds of machining. And some of them are carpentry tools, like your basic speed square is a fantastic metalworking tool. It's great for those boiler making applications. If you're making a steel workbench, you're making the legs, you need 45 degrees for the miters and you need 90 degrees for the square cuts. This is a great way to mark them out. This is a fantastic tool, but it's not precision. Okay, you can get these kinds of quote-unquote engineer's squares. You can get the cheapo ones like this, which are kind of okay for exactly the same kind of work. They're also good for setting up a blade on a saw at 45 degrees because you can just flick the ruler and Bob's your mother's brother, right? You've got a 45 degree reference surface there and you can hold the other surface against the vise and the 45 against the blade. And there's your setup, right? Dead convenient to use for that. You can also mark offsets, but we'll get to that later. The upgrade on this cheapo one is to get a precision set. The difference is, they look exactly the same, but the difference is precision ground steel body, and they're much more precise at 90 and 45, but only if you've got the screw clamped, okay? They've all got a little scriber in the end as well, in case you just need one quickly and your scriber is out of arm's reach and you're holding something in place. So that's great. And the precision engineering ones often come with the center finding adapter where the ruler goes through this end and it allows you to locate around the diameter and mark the center. And if you want to mark, it comes with a protractor jigger as well, so you can put the ruler through there and set, 10 degrees for the cutoffs for the legs on stools or tables or something of that nature. And that works really well as well. So that's one option. But the square no one thinks about, and there's other squares. There's squares like this that hook over the edge and squares like this that hook over the edge slightly differently, and they come in all kinds of different sizes, and they're all useful, right? But the cheapest square that is arguably one of the most useful that you haven't got, but you need, and you don't realize you need it because you haven't used it yet, but once you do, you'd never go back, is this. It's the 1, 2, 3 block. These things are sold in pairs. They're cheap. Their superpower is that they are hardened and they are precisely ground. So you've got 1 inch, 2 inches, and 3 inches. Okay, you can get metric ones as well, which are 25, 50, and 75. But the interesting thing is that 1, 2, 3 is actually a little more useful, especially if you need to set something up off a reference surface and weld something in on top, and you need something to slide in that is about an inch, that's like 25 mil thick, because if you set it up with an inch, you've got 400 microns of clearance, because an inch is 25.4, right? That means you've got 400 microns of clearance, and your 1 inch bar stock will just slide in there just fine. Same thing with 2 inches and 3 inches. You just get that little Goldilocks bit of clearance if you're in the metric world and you need to build something around it that is the size of the stock that has to fit in there with clearance. I hope that makes sense. Anyway, another superpower of these things is you can use them, you can put them on the inside corner of two things that you need to weld together. 1, 2, like that. And you can clamp just across here and across here, and it's precision 90 degrees in all three axes, right? So you've got a shim on your welding bench, 1 inch high, 2 inches high, 3 inches high, 4 inches, 5 inches, 6 inches high. There's your precision shim. Okay, it's brilliant and so useful. They're really machining devices, blocks, whatever, you know, they're really useful for machining on milling machines in particular, and machinists' heads explode when you explain to them that you're going to use these on a welding table. But the reality is they're so cheap that they're super easy to use kind of sacrificially like that. Buy 2 sets. Have a precision set for machining and a ghetto set for all of the other abusive work. This is the only set I've ever bought for abuse. I've stoned it off a few times to deal with a couple of BBs from welding. Still feels pretty good to me, but if I need to do anything precisely on a milling machine, I use the quote-unquote good set. And who cares, because they're so cheap anyway. But another thing you can do with a 1, 2, 3 block is on machines, you typically, or in a car, right? You don't get to pick a big heavy thing up and take it out of the machine or the car and put it in a drill press and make sure the hole that you drill is at 90 degrees. It's just not practical, right? So, for example, I just fitted a 2-axis DRO kit to my milling machine, which involved drilling a whole bunch of M5 and M6 holes into various cast parts of the milling machine in situ, and they had to be pretty square. And I know some dudes think that they can do that. They've got strange mental powers. But even if that's you and you think you're okay at it, it's better if you've got an alignment tool, right? So let's say this is a big heavy thing in a big heavy machine like a car, and I can't pull it out and take it into a drill press and drill it precisely at 90. And I've only got a small amount of space because I'm in that gynecological environment that is the modern automobile. So I can put the corner of a 1, 2, 3 block exactly where that hole's going to go. I can clamp it in place or hold it with one hand, and then I can get in there with a drill and align it up with the corner of the 1, 2, 3 block, which is orthogonal to the surface that I'm drilling, right? And that means that this hole has the maximum chance of being at 90 degrees to the face I'm drilling because I actually have a reference surface to line it up on. And when you think about drills, right, drills suck. Here's my thesis on drills suck. Drills suck because there's no salient feature on the side of this part of the drill body that's in line with the spindle. And that means visually lining it up, I don't have reference surfaces that I can easily look at here and just line it up. They suck like that. Famous YouTuber referred to them as being designed like training shoes, like tennis shoes or something. He's exactly right. Jimmy DeResta, that was. They're all curved, right? So you can't line the drill up. That's almost as if the designer of every battery drill has manufactured it to make it difficult to get to 90 degrees with the drill bit. The only thing that is sort of collinear and observable from the user's point of view is the actual drill bit. So there's your alignment tool for the actual drill bit if you're drilling onto a flat surface. These things rock and you can't damage them. This is a complex thread leading to 2 simple tools that slash the risk of wasting time and money, which could be hours and hundreds of thousands of dollars, depending on the thing that you are making and how big the mistake is that you make, how long down the track into making it, right? If you have to scrap a part and you've got 2 days of your time invested in making it because you made a measurement error, that's a freaking disaster, okay? Or if you've got to cut 20 things up, let's say, you've got to make them 87 millimeters long each, and you're just measuring them with a ruler or a tape measure or something. So you pull your ruler out of your ghetto square and you're just marking each one and cutting it like a DIYer. Then you just know that by the time you get to component number 13 to 17, somewhere in that range, you're going to goof off mentally. And then all it takes is a hot chick with great cans walking past, and you'll mark it. You'll mark it. There's a 7. It'll be 77, right? It, or 97. And if you've only just got enough material to make the requisite number of parts to do that particular job, that's a freaking disaster, because you've got to get in the car, you've got to go somewhere, you've got to buy that extra piece of material, you've got to come back, you'll be cursing the whole way, right? The reason is that measurement opens the door to variability and error, because if you're measuring 87, every time you put your scriber on the part and you scribe a line, it's not going to be 87. It's going to be 86 and a bit, or 88 and a bit, whatever it's going to be. It's not going to be 87, is it, right? So you got to think about ways of taking that variability and risk out of the equation. And the obvious way is to set up your square like that at 87, right? So there's your reference mark, and you scribe the end. Then you don't have to measure it. You just have to mark it, dude. Everyone's going to be marked in the same spot, and therefore it's up to you to cut it in the right place, but you've taken all of the risk of variability and all of the risk of error, and you've sidelined it. And this is not even the best tool to do this with, right? Although it is pretty good at marking these offsets. You can use one of these. And these are really clever because they've got a vernier scale. And just to digress, the place that people first encounter a vernier scale is one of these basic calipers. Now, I always get in arguments with the great unwashed about this, because people buy digital calipers these days and they think they're more accurate. And I would argue the digital calipers are ever so slightly shit because they're amenable to damage. The cheap ones are unreliable. They go flat and you can't use them. And they make you think you're taking a really accurate measurement, even though your technique might be shit. So the way to get an accurate measurement is you've got to have good technique with the calipers, because you're physically feeling something, right? It's not good enough just to have 3 decimal places of quote unquote accuracy on the display if your technique is shit. So there's that. These ones never go flat. You can easily resolve by naked eye down to 50 microns, which is like 2/2000ths of an inch kind of thing, you know. That's pretty accurate. For most farm work, that's accurate enough. The batteries never go flat. And you can use them in all conditions, and they're not as expensive anyway, so they're pretty robust. Just don't leave them out like this, because if you drop them on the end, that kind of screws with them quite a bit. So don't do that. But anyway, the vernier scale, learn how to use one. I'm not going to teach you how to use one in this video, but if you want a video about that, I can show you that. But the vernier scale is great because it makes sub-millimeter accuracy accessible without opening the door to the risk of flat batteries and whatever. 9 o'clock at night, you're not getting a battery, are you? If you're working in your shed instead of wasting your life in front of Netflix. So the vernier scale also exists on a device such as this, which is just a marking off gauge. It's got a piece that moves up and down relative to a reference surface that you scribe on, and it hooks onto whatever you want to mark. So let's say I want to mark something there. I use my vernier scale to get within like 1/10 of a millimeter, so super accurate. Every part's going to be consistent, and then all I do is I put my part wherever it is. I'll try and do it close enough so you can see it like that. I just hook it over, and let's say I've got to mark holes on that line. I just scribe on that line, and that's where the holes are going to go. And if the holes are going to go in, if I'm going to put a hole in there, like roughly in the center, but exactly in the center, if I choose the right distance, there's the center. I can feel that with my center punch and use my Jedi superpower, and I haven't had to physically measure anything. I've just had to mark it, right? So the risk of getting that wrong on one occasion is sidelined. All I have to do is hook it and scribe, and hook it and scribe, and there we go. And if you're doing this 50 times, you save a shit ton of time and also the cognitive bandwidth of reading the scale. You just get it done quicker with less risk. So these marking off gauges are freaking brilliant. You will curse not having had one for the earlier part of your life. As soon as you acquire one, you use it all the time, and they're super robust as well. An extension of this idea is the same sort of vernier scale deal, but what we've got here is a roller there, which is like a rolling reference surface that's always the same edge, there's always the same distance from the cutting edge of this carbide scriber. So once I set that with my vernier scale, I can be easily within 1/10 of a millimeter, and then to mark something out, I just roll it down the end. So if I need to drill a series of holes on this line, that's such an easy way to mark, you know, exactly where I need to mark. And the carbide scriber does a good job cutting a bit of a trench in there, which you can feel with your center punch and use your Jedi hole locating tactile sensors to accomplish. And nobody else is going to be impressed with that except you, but you'll be pretty freaking impressed with it when you do it. So this kind of marking gauge is awesome as well, but frankly, they're both good. And the superpower of these is, let's say you've got a typical job to do. You're building a bench, or 2 benches in this case. It's going to have 8 feet, okay? 4 posts, 8 feet. They're going to have 4 holes for the casters in the bottom. So that's 32 holes. And let's say you want them 20 in from each face. That's a lot of marking out, right? That's 32 holes. That's 64 X's and Y's that you have to mark. And then, do you really want to measure that with a ruler and open the door to variability? The variability might not matter, but the time and the cognitive bandwidth. If you've got this and you mark your, whatever it is, 25 millimeters in, it's just bang, 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 bang. There's your marking, right? It's done in a fraction of the time, and you haven't had to worry about reading a scale, hooking it properly with a square, and you know, it's just so much simpler to streamline the marking out of anything using a tool like this. And the end product is so much better and more accurate. Sometimes that matters and sometimes it doesn't. But you will not waste nearly as much time in your future life whipping down to some steel merchant to buy an extra piece of whatever because you just buggered something up properly, or welding up a hole that's in the wrong place and then grinding it flat and then going again. Such a pain in the ass, and you curse yourself when that happens. So get one or both of these marking off tools, or at the very least a square like that, so that you don't have to devote all of this time to physically measuring a scale and then marking a line, because that sucks. It properly sucks. And so many DIYers do everything that way. There is one battery-powered tool on this list, and this is it, dude. It is an angle box. These things are super useful in a machine environment. If you've got a drill press, for example, and you want to make sure that the table of your drill press is at 90 degrees to the quill, this is the easiest way to do exactly that. When you turn it on, its superpower is that it feels gravity, and it tells you if something is flat or not. So it'll tell you absolutely if something is level or not. But you can also arbitrarily decide that a particular angle is level, and then you can just zero it. Now I can't see that at all, but hopefully that is kind of zeroed and you can see that it's tilted over. And if not, then I've just got that wrong and you'll have to take my word for it. But these things are Super useful if you are starting some machining journey. There's all kinds of different examples of them. Here's another one. Like, they all do the same basic thing though. They've got like an accelerometer thingo inside them, I suppose. I don't know how they actually work, but they measure these angles and they measure them repeatedly. They're super useful if you're making something like, I just made these clamps. They're for a drill press vise. They hook over the drill press vise and they screw down and hold the vise in position. You just put a threaded stud through them with a nut and a washer on top, kind of like that, goes in a T-slot, and then, you know, it clamps the whole clamp together, holds the vise to the table, and it gives you the ability to do repeatable holes without measuring or marking anything. So that's kind of lovely. I decided that I wanted them to look half elegant though, so I put this taper towards the top. And the way to taper that is I just put the stock in the vise of the milling machine, right? And then you put your angle block in and you cant it over it, whatever I decided, 7 or 10 degrees or something. And it's not precision, but it's accurate enough to look the part. So then you just skim it flat like that. And then you flip it, you set it up at 10 degrees or 7, whatever it is, and then you skim it again. And that's like repeatable all day long, and you haven't had to go and buy some sort of ridiculously expensive precision angle block, which would be the way to produce the same thing, but a precise variant of the same thing, which is not necessary if you're just clamping a vise to a freaking table. Angle blocks are also really good if you're making angled legs on anything, because most people cut the legs off at 10 degrees, then they weld them on, and they use the cut as the reference, right? Then they weld them on like that. But I would argue that the best way to do this is to just tack here and here, right? And then you've essentially got a hinge that you can nudge in place. You stick your angle block on the side and you read the angle. Like, let's say it's this way. Angle block on the side, tacks here. It's got to go out a little bit, great. It's got to go in a little bit, great. You can achieve that. And the thing that matters with tables and stools and things of that nature is not so much whether it's 10 degrees or 10.5 or 10.2. It looks really amateur if one is 10 and one is 7. That looks terrible. So a way to ensure consistency there is just square them up, get the angle right just before you weld them, and measure it in situ rather than just doing the DIY way, which is to pretend that the angle you've cut the end of the leg is in any way precise and setting you up for success as you're actually fabbing the thing up. So angle blocks, you use them all the time, and you'll keep them with you on your machining quote-unquote journey, because lots of things need to be set up near enough 90 degrees. And the easiest way to do that is with electronics. How many times have you pulled something apart, you've pulled a nut off something or a bolt out or a set screw, whatever, and it's more or less cactus and you need to replace it, but you need to buy the right fastener because it's screwing straight into an engine block or something of that nature, some pre-existing expensive component that you can't change. So you need to buy the right fastener, and you need to know what the right thread is, and that means you need to have the secret sauce for that. So the machinist way to do that is to get a set of these babies, which is thread gauges. There's dozens upon dozens of them for all different kinds of threads. This set is metric and unified and Whitworth. So all the different thread pitches are on these toothy gauge thingos, right? And you've just got to find the right one. And then you have to measure the diameter of the shaft, and you have to figure out whether it's metric or imperial, right? That's a pain in the ass. It's a proper pain in the ass. And you have to speak fluent thread to do it, which sucks, because if you haven't worked in industry, you probably don't speak thread, okay? Thankfully, there's a better way, a more convenient way in any case. And it's one of these. I got this from tradetools.com. They've got this in-house brand of imported tools called Renegade Industrial, comes straight from China. But a lot of the stuff is really high quality. They've got another one called Force too, which comes out of Taiwan, makes some fantastic wrenches and things of that nature. So Trade Tools does not sponsor me, but I buy a lot of shit from them because this Renegade stuff and this Force stuff is really good in my estimation. Big, who doesn't want a big 25mm brass drift to punch something out of something else without damaging it? Like, yay. That's from Renegade Industrial as well. So are my calipers that I was just showing you. I just use them. They don't sponsor me. Okay, so the beauty of this is that male and female threads, metric and unified. So metric coarse and metric fine plus the same thing in unified. So UNC and UNF. Brilliant, okay? And this means that you pull your bolt or your set screw, whatever, out of something and you look at it and you say, that could be 3/8 16 UNC or M10 by 1.5, right? And if you're not a proper Jedi and you're not doing it every day, can you tell which one it is? It's one of the two. It's got to be one of the two because it's not 12 and it's not 9/16, right? So it's definitely 3/8. But which one is it? So you try your 3/8 16 course and it just binds almost immediately on the way in. Therefore, it's not that one. And then you just try your M10 by 1.5. Straight in, dude, like it's meant to be there. And therefore, you know that this thread is M10 coarse by 1.5, right? Not M10 fine, which would be M10 by 1.25. And they've got M10 by 1.25 here, and you can try that, and it binds. Okay, it doesn't go in any further than that. Ergo, you know it is not that, okay? This is brilliant. You could do the same thing with nuts on the studs that match the holes. The only disadvantage of this, frankly, is that you can't really take it over to the engine block and wind it into a tapped hole and figure out what the tapped hole is. So that is an impediment to doing that particular mode of thread investigation, right? And I suppose if you've got a big collection of fasteners, you can just get a representative sample and take them over there and see which one fits. That's fine. But you can also try this. This is essentially exactly the same thing, but it's Whitworth, unified, and metric. So UNF, UNC, and metric coarse and fine as well, plus a few token Whitworths here for older machineries and Land Rovers from 1960 and things of that nature. And this is the superpower of this set, is that you could take one particular example in your hand and wind it into a tapped hole way over there out in the field with all kinds of other gynecological freaking impediments to access that would not see you wind big red plate on anytime soon. I got this one from Hare and Forbes, like Machinery House here in Sydney. They don't sponsor me either, but I get a lot of my stuff from them. This is really good also, and it fits in a toolbox if you need it to. If you're doing a lot of thread replacement and things of that nature, I'd rather be carrying this around than a big unwieldy plate like that. But a big unwieldy plate like that is just fine if it's right here on your workbench and you're just pulling something apart and you need to get that down, test it now. It's much clearer. In particular, it's much easier just to read what thread it is there than read the side, whichever side is actually laser engraved on these babies. So it's equally easy to find the thread that fits, but pretty hard to read that from time to time, depending on the lighting. I don't know how often you build big stuff, like construction type stuff with beams and channels and columns and things of that nature, or just heavy stuff where you have to line two different components up and then get a bolt through the holes. But that's a thing. In industry, that's a thing. It was a real thing for me recently when I built my 4-post hoist over in the other workshop, because the main columns, the ramps, if you like, that you park the car on before the cross beams lift the whole thing up, they need to get lined up, and you put bolts through them to stop the whole thing unmeccanoing itself under load. And lining up those holes is a real challenge because the ramps themselves weigh, I don't know, the one with all the hydraulics in it's got to weigh more than a couple of 100 kilos, and it's hard to nudge backwards and forwards precisely, you know? And that's why you need one of these. A podger, like a tapered, this is actually a tapered punch, but I mainly use it for alignment of big holes. You can use smaller punches as well, and that's fine, but much easier to, once you've got a hole kind of overlapped a little bit, you just drive the tapered punch in and nudge it to one side by hitting it on the side with a hammer if you need to, with your nice brass hammer that you'll just thank your lucky stars you discovered 40 years ago, right? This is a great way to align those big, heavy things without putting your fingers at risk, right? Really, you want to end the job with the same number of fingers you started with, right? This is a great way of doing that. They also make podger spanners like this. This is from the mighty King Dick. It's a ratcheting podger. I think this one is 18 and 24. 18 on this side and 24 on the other side. So kind of a precision instrument. Wouldn't want to hit on this anytime soon, but same sort of alignment deal up this end. So taper in there, nudge it one way or the other, and emerge with 10 fingers intact, dude. It's brilliant. If you haven't got a tapered punch like that, I think the easiest way to do it is the most cost-effective way. I just tried this. This is another Trade Tools purchase, right? It's just a comprehensive set of punches and chisels. And it's the biggest item in there is that kind of alignment punch. Brilliant, right? And if you've got a slightly smaller thing that you need to align, like on a piece of yard equipment or something, you just use a slightly smaller tapered punch. The brilliant thing about all of these is that they're made out of tool steel, like some chrome vanadium, whatever. They'll only be hardened at the absolute tip. They'll be pretty much annealed from here back. So the annealed bit is pretty soft. It's unlikely you'll snap it off. Just make sure that the hard part of the tip is past the alignment job and not part of the leverage equation, and you'll have yourself a pretty robust tool that can also be used to hit out, you know, tapered pins when you need to disassemble, I don't know, the spindle on a milling machine or something like that, somewhat down the track. But these things are dirt cheap and a great way of acquiring all the punches and chisels that you probably ever need. Just tradetools.com and do the appropriate search for like 16-piece punch and chisel set. Why not search for that? See if it comes up. It'll be an intelligence test. If you're a politician, you probably won't do it successfully. Everyone else, 2 thumbs up. While we're down there, as it were, talking about chisels and punches and things of that nature, let's talk about chisels, like cold chisels, because you probably got a cold chisel in your toolkit. It's probably something like that. Cold chisels are, in my estimation, particularly since the rise of the angle grinder, cold chisels have become kind of useless. But everyone's got one, seemingly. And yet, they're not useless. They're just ground wrong, okay? Stick with me on this, because here's a hack you can do with any cold chisel that will make it useful. Blacksmiths have this thing. It's called a fuller, which is essentially a hot chisel. It's a hot cutting chisel. F-U-L-L-E-R. It's a fuller. It usually fits in, I forget which one it is. It's either the Hardy hole or the Pritchell hole. It's the square one, whichever one that is. Someone will know. I think it's a Hardy hole, but I might be wrong. Anyway, the fuller fits into the square hole on the anvil. Chisel end sits up like this, and you put a corresponding thing on top and you hot cut a piece of stock, right? So a cold chisel is essentially a fuller for use on cold stock, hence the name. It's a cold chisel. You belt it through a piece of round bar and you cut it in half. But these days, I think most people would use an angle grinder to do the same job. So this kind of 90-degree cutting is not very useful. And some of the things that you might want to do with a cold chisel are not very useful when the cutting edge is ground like this. See, cold chisels are like this. They've got these primary bevels that are quite tapered, and then they've got a converging angle in the center that's about 60 degrees. Okay, so if that's 45, they're about that, 60 degrees. It's not an exact science. It depends on the material you want to cut. But the conventional angle to cut a cold chisel at is 60 degrees. And the secondary bevels there, right up the top, they're at about 60 degrees. That's useless, okay? Because if you've got, for example, one thing you might want to do, you might want to make an extension for a table, and that generally means you'll get 2 bits of square hollow section, one that telescopes inside the other bit. So the smaller bit has to run down the inside of the tube, the bigger tube. The problem with that is if it's a close fit, there's a welded seam inside the bigger tube because they start with a bit of flat bar, they fold it up in a die and they seam weld it, and that's how you get your square tube. There's a bit of flashing off the weld, and it always occludes the inner space of the tube, and if you want to make it telescope properly, you need to clean that up somehow. And if you try to get a chisel in there with the cutting tip engaged, you only get about that far in, and then then the edge comes off the ground as you get further in because you can't slide it past the opening and leave the cutting tip engaged. You're geometrically rooted and you're back to gynecology in a metal shop, right? That freaking sucks. Likewise, if you've got all these BBs on the table from a big welding job and you want to clean up your table at the end of the job, it's not very useful having that 60-degree edge like that on the chisel. That freaking sucks. But having a big heavy chisel like that to deal with the BBs would be excellent. Having a big heavy chisel to just get the flashing off the welding on the inside of a tube would be awesome. So what do? You take your chisel that comes out of the box like that and you make it into a side cutting chisel. Now what you can see there is that, hopefully you can see that, I've ground this one, but it's the same angle. It's just the orientation's different. So you start with one of the primary bevels as one of the reference surfaces of the 60-degree grind, and then you just grind the rest of the 60-degree over the top and wait for, if you're doing it the same way, you just wait for this secondary bevel to disappear as you're grinding it, and just grind a bit, dip it in the water, grind a bit, dip it in the water like that. If you want to be a total nonce, you can check the angle, like 60 degrees like that, near enough kind of thing. There's your 60. 60 degrees like that. There you go. I don't know if you can see that. 60 degrees like that. There you go. Beautiful. When you do that, all of a sudden, you've got the same cutting angle. So it'll be just as effective for actually cutting steel. But what you get is, you get cutting edge engagement all the way along as far as you need to reach. For the length of the chisel, you can keep knocking that welding flashing off, no problem. It's a far better scraper because it's more in line with how you're pushing it. If you don't have a milling machine, you want to cut a slot in a piece of steel, you probably drill holes right along the length of the slot. Then you put them in a vise with some nice hardened jaws, a nice robust vise. You can use a chisel like this to knock out the stock in between the holes and then just refine it with a file. One of these babies is going to cost you, I don't know, $20 or something for a half decent one. The grinding is essentially free if you've got a grinder, and that's a lot cheaper than a milling machine, because I think I paid all up about, I don't know, $4,000 or something for that DMF 44 over there by the time I put the power feed on the X and the X and Y DRO on it. So I'm probably into it for about $4,000, $4,500, something like that. It's a lovely machine, but it's a lot more expensive if you just want to do the odd very basic piece of chiseling. So I would suggest that you get your basic chisel set. You might want to leave the biggest one for a bit of masonry or whatever, but get the other 3 smaller ones that come in the kit and just turn them into side cutters. Because when you've got these side cutters, you'll be amazed at how often you reach for the side cutting chisel to just finesse something quickly that might otherwise take you 5 minutes to file, if that's the alternative. If filing it is the alternative, you can rough it in with a chisel, wear safety glasses. Anytime you pick up a hammer, wear safety glasses. In fact, wear safety glasses, okay? Hammering is a particularly dangerous activity though, because there's a lot of energy being transmitted quickly, so the actual impact blow is powerful. If something breaks off the chisel or the mushrooming end of the hammer, it can rebound and hit you in the face, so wear safety glasses. Same thing with chiseling. The thing that you chisel away, when it breaks free, it can acquire a lot of energy and rebound back towards you. So safety glasses, not optional, but side cutting chisels are a superpower, and it's almost like going back in time to a land before the angle grinder. And angle grinders have their place, don't get me wrong, I like them, but they're a very dangerous tool and they're not ideal for everything. The final tool I want to get to here is, in a sense, a bit of a luxury. At least it is if you go as far down this rabbit hole as you possibly can. But realistically, we've gotten to a point where screws and screwdrivers have adapted a great deal in the past 25 years. We've got all kinds of different screw heads and all kinds of different mechanisms for driving them home. Everyone's got a battery impact driver now, for example, so that hex driver thing that drives all of those different heads it's proliferated throughout toolboxes around the world. And obviously you can use your battery driver, like your battery driver is a thing, okay? It's a great tool because it's got so many applications, but I wouldn't be using your battery driver for too much automotive stuff, because too much impact is a bad thing unless you really think about what you're applying it to. So horses for courses on the issue of that kind of driving. But because this is a standardized thing now, you can get an adapter from battery impact driver to 1/4 inch or battery impact driver to 3/8, for example. Fantastic. Why not take the maximum possible advantage of that? The obvious way to do that is to start with some kind of basic adapter that turns this into a nut runner for every nut in your socket kit. So, you know, you can be way over there in that gynecological environment and taking up all the slack without having to have your fingers in there like that, right? That's really useful. But it gets kind of better than that if you spend a little bit more money. I forget, this is just some cheapy no-name job. But there's a screwdriver handle like that from Vera, W-E-R-A. Now, the thing about Vera is that they're almost Knipex. Knipex is designed and manufactured in Germany. They're a great tool. Vera is designed in Germany but generally manufactured in the Czech Republic. They're quite innovative though. They do a great job with integrated tool kits that function really well together, which we'll get to in just a sec. This one ratchets, so it can be not ratchet. So just a normal screwdriver, not ratchet. It's got a few degrees of play in it, but then you can set it for undoing, which is great in that sort of tight environment as well. And it means that you don't have to reposition your hand so much. So it's less fatiguing when you're just backing a fastener all the way off a thread that might be a bit excessively long, sort of thing. Take some of the fatigue away from that, and then obviously you can run it back in the same way. So that's a great idea. But the one I really like, which is quite expensive because you've got to buy it in a kit. This is a Vera kit, right? It's called a Tool Check Plus. It comes with this thing, which is fantastic. So useful, called a Tool Check. It's got some 1/4 inch drive sockets and a bunch of screwdriver bits as well, and a tiny little cute as ratchet for the same hex type system. Beautiful little ratchet. So great for working on small whatever. You know, really nice when you haven't got hardly any room to move. This thing is fantastic. But the thing that I really do like is what it's wrapped in, because you get a kind of every different screwdriver, which is fantastic, and a couple of Allen keys as well. You get Posi drive and Phillips 1 and 2 and 3, and a couple of flat blades, and a couple that I can't really identify, that I don't really know what they are. Torx as well as that. But the thing that's really clever about this is a planetary drive screwdriver handle. And what this does, right, it's got two different settings. It's just a normal screwdriver handle like this one we started with. But if you set it in planetary mode, check this out. This is in normal mode at the moment, and it just turns 1 for 1. I think you can probably see that, like 1 for 1. Brilliant. But when I click the end, I engage the planetary gear set, and you can see how much faster the bit is actually turning. So if you've got 24 screws to put in on some oil pan and you don't want to get a power tool on it and you just want to run up the threads and get them finger tight, this is such a good way of doing it, so much less fatiguing. Obviously, you lose mechanical advantage like this because it's like 3 for 1, right? You lose a bit of mechanical advantage, but if you're just running a fastener up a thread to the point of engagement, absolutely brilliant, right? And it'll do the same thing in reverse for undoing, which slashes time. And if you're just in that environment where you don't have a power tool and you don't have like a power socket, power ratchet driver kind of thing, and you don't have your impact driver with you, but you've got your little Vera tool check. This thing is so good, dude. It's a superpower. It really is. They're quite expensive, but to me, they're kind of a lifetime purchase, and you will not. You probably regret the money that you spent up front on something like this, but once it's in your tool bag, quite the opposite. You will not regret owning it. And look at the space it takes up. When you think about all the drivers you've got, plus all of the sockets you've got, your little ratchet and all of that stuff, like this is a triumph of complexity. And one of the things that Germans are really good at. I know this has been a reasonably long video, but I hope it's helped you by just nudging the thought process one way to expand your working envelope, to take you closer to the achievement of the projects that you'd really like to get done, whether that's out there working on your car, modifying something, or just restoring something back into the condition it was more like when it rolled off the factory floor. Hope that's helped, or you might want to start making something in your own workshop. This is kind of how you can integrate metal trade stuff into the DIY mental framework without breaking the bank. And if that's helped you, my work is done. And if you'd like me to cover some other stuff like this, let me know what you want, and maybe you want me to make a couple of these hammers and show you how from square stock and round stock, whatever. I don't know. Over to you. Let me know in the comments, and thank you very much for watching.